Welcome to EDU World Space.
Suppose that this series has positive terms. So here we're just supposing that an is bigger than 0 for all n. And we're given an inequality for the partial sum Sn. Recall Sn is the sum of the a's all the way up to n. In this case, we don't know what the starting point is because the sigma notation, it doesn't tell us where to start, but it doesn't matter what the starting point is. So if we were to just start at 1, we would add up all the a's until we get to an. That's the nth partial sum. And we are told that no matter how big n is, this thing is always less than 1,000. And now we'd like to explain why this sum converges. Well, first of all, since an is bigger than 0 for all n, what can we say about the sequence Sn? Is it increasing or decreasing? I claim it's increasing. So since an's bigger than 0 for all n, Sn plus 1 is bigger than Sn. And the way to see this is just to subtract. So if we subtract these using this definition up here, you'll end up with an plus 1. So maybe I could actually show that. Let me go a few steps back here. So this is a1 all the way up to an, and then an plus 1. That's Sn plus 1 there. And then over here, we have a minus a1 all the way up to an. And then when you subtract, you could cancel everything from a1 all the way up to an, but you're left over with this an plus 1. And by assumption, all the an's are positive, so this must be a positive number. This means that Sn plus 1 is bigger than Sn. You get that by just adding Sn to both sides of this inequality. So this means that Sn is bounded. The reason it's bounded is not due to what we just showed. The reason it's bounded is due to this upper bound that's given. And increasing, which is also called monotone. So the Sn converges. In other words, this thing right here converges by, this is from section 11.1, and there's a name for this theorem. This is called, let me find the name of this theorem. I believe it's the monotone sequence theorem. This is from 11.1, yes, monotone sequence theorem. Which says that any bounded monotone sequence must converge. Therefore, this converges. So that's our final answer.